Okay, in our last class, we begin with the basic idea of normal distribution, and then we discuss that this normal distribution, can be transferred into standard normal distribution. By the way, normal distribution sometimes called bell curve or Gaussian distribution, and we learn how to convert the normal distribution into standard normal distribution, which is actually the Z distribution, Z curve, like here. The characteristics of Z curve is that the mean mu is equal to 0 for Z curve, and we also discussed that 68.26% of the area lies within one standard deviation in the normal curve, and 95.44% of the area lies within 2 standard deviation, and 99.74% of the area lies within 3 standard deviation. We discussed that already, and the same applies to Z curve also. Okay, so 68.26% of the data or the area lies within one standard deviation. Okay, the same property is applied to Z curve as well. We discussed that in our last class. We also learned a formula how to convert the normal curve into a Z curve using this formula, finding the Z value. And then we did this example 4, and we learned how to find the area when the Z value is given. In another word, how to find the probability when the Z value is given using the Z table. That's what we did last class. Today, a little bit of an application of this concept. Okay, how can we solve real world problems using the concept that we learned in our previous class? So question number 5, 6, 7, and 8 are related. Let's begin with example 5. After an exam, you learn that the mean for the class is 60. Okay, let me write what is given. Here, given that mean for this distribution, normal distribution, is given to be 60 with a standard deviation of 10. Okay, and suppose your exam score is 70, so X is given 70. Now in part A, what is your Z score? Can you please find the Z score for this? Z score for 70. We know the formula, right? Z equals X minus mu over standard deviation, which is 70 minus 60 divided by 10 equals 1. Any question? Okay, now let us look at where relative to the mean does your score lie. So that means in this context, in your class, what percentile you are at. We want to calculate, okay? How good you are doing in relation to other students in the same class. That's what we are trying to find in part B. In another word, we want to find Z probability of Z less than or equal to 1. That's all we need to find. Okay, so that means let us look at the table. Z equals 1. let's go all the way down. We have the table. I believe you also have the table in your handout. 1, positive 1, z equals positive 1. So 1 means 1 means 1.00, right? So 1.0 is right there. So you see, and 0. So this is the value, 0.8413. Let's go all the way up, 0.8413. What does that mean? So this means you are at 84.13 percentile. Now part C, what is the probability associated with your score? Z score table, okay? Use the Z score table. Well, we actually use the Z score table. In another word, what this part C is asking you is that how many of the students did better than you and how many of the students did poorer than you. You know that you are at 84.13 percentile. That means 84.13% of the student in that class score below your score, below yours, and 100% minus 84.13%, which is equal to how much is that? Is that 15.87% did better than you. Okay, score above yours, score above yours. So that means 15.87% of the student did better than you, and 84.13% student did not better than you, poorer than you. Okay, does that make sense? Everyone is okay with this? So in other words, 15.87 percent of the student did better than you. Okay, that's the meaning. And these kind of score are used for most of the standardized tests like SAT, ZRE, GMAT. So those tests use this score. What percentile you are at, and the university will can compare how many of the student score better than you and how many of the student score below yours. Based on that, the admission officer will send the offer of admission in many universities. That's what they do. Now let's look at example 6. In the above example 4, what if your score is 72? I would like you to try this. If your score is 72, at what percentile you are at? In another word, how many percentage of the student did better than you and how many of the student did poorer than you. I want you to try this, okay? Try this yourself just for fun. What is given here is, we already know mu is already given 60, the standard deviation is already given 10, and then in this case your x is 72. So z value for 72, you can calculate that easily. Z equals x minus mu over standard deviation. And yeah, try this. I'll give you a couple of minutes. Okay, you guys got this 0.8849. So many of you got the same thing. That means it should be the correct answer. Or you can say 88.49 percentile. Okay, so the meaning is, this means with a score of 72, you are at 88.49 percentile. In other words, 88.49% scored below yours, and 100% minus 88.49%, which is equal to, is that 11.51? 11.51% is scored above yours. So that means you are on the top 11.51% among all the students who are taking this test. Okay, in this situation, in this scenario, in this case, you are on the top 11.5%. All right. Any question? Example 6 is done. Now let's look at example 7. Again, remember in this case also, suppose you have 72 and your classmate, suppose you have scored 72 and your classmate has scored 55, for example. Percentage or non-percentage? It may be percentage if the full mark of the test is 72, or let us consider simply 72. It doesn't matter, it's the same thing. How much better is your score in the context of this situation in that class? How much better is your score? That's the question we want to find. Okay, so what we want to do is, remember here also what is given is mu is already given 60, as we know from before. The standard deviation is already given 10. Now we have two x value. One x is 72 and another x is 55. You can write x1, x2, or simply this one. Okay, so now we can find z value for 72. Z equals x minus mu over standard deviation, and z value for 55 means z equals x minus mu over standard deviation. Guys, I want you to calculate both of these values, okay? 72 minus mu is 60 divided by 10, which is 1.2. And this guy is 55 minus 60 divided by 10 equals 0.5. Okay, any question so far? Now, in order to answer how much better is your score, what you need to do is we first find the probability between these two values. Okay, we know the Z value. One Z value is this negative, by the way. This is negative, so negative 0.5 Z 1.2. Let us calculate this. This means probability of Z, because the Z curve, Z table gives the area on the left hand side. So we are considering this to be equal to Z less than or equal to negative 0.5 minus, sorry, 1.2 minus probability of Z less than or equal to negative 0.5. So let us calculate these values. 1.2, go all the way down, and 1.2. And another is negative 0.5. Let's go all the way down. I know you guys already got the answer, and you have that answer given in the chat box, but I just want to do it by myself. One value that we are looking for is negative 0.5, which is right there. Negative 0.5 means negative 0.50, and this is the value. Okay, please remember this, 0.3085. That's one value we are looking for. Okay, because you see, as you can see here, this negative 0.5 and 0 is right there. It's all the way here. So that's the value. And another value we are looking for is 1.2 positive. So 1.2 positive is 1.2 means 1.20. So 1.2 here and 0 is there. So that's the value. I think we have already done this before. Anyway, so 0.8849. Okay, let me write this down. Okay, guys, I'm just copying the answer from the chat box that you have given. And so this, the first value is, let me write here, PZ is less than or equal to 1.2 is 0.8849 minus this value is, again, I forgot. What is that again? 3085. Did I copy the right thing here? Let me check my answer. Okay, yes. So when we subtract, so you're gonna get 0.5764. Okay, what this means is your mark is 57.64. As you know that this can be expressed as 57.64%. So your mark is 57.64% better than your classmate. Better than your classmate, classmate's mark. Okay, that's how we can compare. Any questions so far? Okay, let's try one more question just for fun. Okay, example 8. Let's say your classmate won't show you the mark, because sometimes people hesitate to show their mark to other people. Suppose that your friend doesn't want to show you the mark, but you want to guess what would be his mark. You can guess randomly, but it is always better to get to do an educated guess, okay, or informed guess. Informed guess, sometimes called educated guess. Educated guess. Okay, how can you make an informed guess about what your friend classmate's mark might be? So here is a question. What is the probability that your classmate has a mark between 60 and 70%? So what is the probability that even though your friend, your classmate doesn't want to show his score to you, but you can guess, what is the probability that this guy is score between 60 and 70? Let's calculate this. I trust that you can do this by yourself. I'm going to do it here, but try it by yourself, okay? Again, in this question, what is given is mean is given 60, standard deviation is given 10. And now we have mark between 60. Okay, let us find Z value for 60, which is Z equals X minus mu over standard deviation, which is X is 60 minus 60 divided by 10. That's going to give you 0. And Z value for X equals 70. That's going to give me X minus mu over standard deviation. Again, the formula is 70 minus 60 divided by 10, which is 1. So all we need to find here is, so we find probability that lies between 0 and 1, which means probability of 1 minus probability of 0, and that's gonna give me, I don't know how much is that. Can you guys look at the table and let me know what is the value? Z equals 1. 1 means 1.00. What is the probability? Look at the table, and when Z equals to 0.00, what is the probability? I know that this will be 0. It will be half, because the mean is right there, mean equal to 0 for the Z curve. I know that this one is 0.5000. Even without looking at table, I can tell that. And now I want your help. What is the value for Z equals 1? And you guys already replied there. 0.3413. Okay, 0.3413. Oh, no, I think, oh, you mean that this one is, the result is 0. Okay. You mean the result is 0.3413. Okay, thank you. And so what is this value? Okay, 8413. Okay, 0.8413. 8413. Thank you guys. So this one, or you can say 34.13 percentile. So what it means is, this means the probability that your classmates score is, maybe I can write, there is a, let me write this nicely, okay? Let me write this way, language. This means there is a 34.13% chances that your classmate score lies or falls between 60 and 70. Okay, that's how we can calculate. We can say that there is a 34% chances that your classmate has a score of 60 and 70. Any questions so far? Can you think of these questions from a different perspective? Can you think another method to solve this problem? Let's say this is method 1. Now try to figure out whether it can be solved by using the property of normal distribution. Can we do that? Method 2. So if you look at what is given here is, in this question, what is given is mu is given 60, standard deviation is given 10, and what we want to find is, we want to find the area between 60 and 70. So that means this is not the Z curve, this is a just normal curve, okay? Normal curve. Mu is given 60. Standard deviation is 10. So that means, let's say this one is your 70, which is, and this one will be 50. So this area right here, it is one standard deviation from mean. So that is, mu minus standard deviation is this point, and mu plus standard deviation is this point. So we want to find this part right here. This is what we want to find. Okay, we want to find the area of this part. Can somebody tell me how we can do it? Do you know anything for normal distribution, any information, how much area will lie within one standard deviation from the mean? Do we know that? We know for normal distribution, probability distribution, 68 point, what percentage again? Can you check your graph earlier and tell me how much is that? 68.26% area falls or lies within one standard deviation from the mean, right? One standard deviation from mean. We know this. So that means this area right here, this one plus this one together. Let's say this is A, this is B. So A plus B together is 68.26. By the way, the normal curve is symmetric. Okay. So in this case, area A equals to area B. So the normal curves are symmetric, so they are equal. Therefore, just by using the property of the normal curve, we can say that so probability between x between 60 and 70 equals, it should be 68.26 percentage divided by 2. Does that make sense to everyone? Because both of these area together is 68.26. But since we are talking about only the area from 60 to 70, so that's going to give me, if you divide that by 2, it should be 34.13 percentile. Did we get the same thing earlier? Let us check. What do we get? Yeah, we got the same thing, right? And of course, they must be same. It's just a different method. Any question, guys? Okay, now going, if you don't have any question, then this example 9 we already did in our last class. And if you want, you can try it again just for fun. But let's look at example 10 now. Guys, I want you to take a few minutes and try this example 10 on your own. Okay, I will wait for you guys. All right, so let's try each of these very quickly. Find what is given here is that given mu equals 75, standard deviation is given 16. And then find the probability that a randomly selected person lives less than 88 years. So part A, first you find Z value for x equals 88, which is x minus mu over the standard deviation, which is 88 minus 75 over 16, which is approximately 0.81. And so the probability of z less than or equal to 0.81 is given by the formula, I mean, given just looking at, and you already wrote there. I trust that you wrote in the chat box, and I trust that that is the correct answer. It's going to be 0.7910, or you can say approximately 79%. Part B, find the probability that a randomly selected person lives more than 67 years. Okay, so Z value for x equals 67 is that Z equals x minus mu over standard deviation, which is 67 minus 75 over 16, which is equal to negative 0.5, and probability of z less than or equal to 0. Negative 0.5 equals, how much is that? 30.0.0.85, I believe, right? Yeah. Now remember one thing, we are looking for more than 67. So what we are trying to find here is, this is a Z curve. So mu equal to 0. So we're looking for negative 0.5 is right there. So more than means we are talking about this area. Okay, this area right here, greater than, on the right side. So how do we find that? So the probability more than 67 years is given by probability of, given by, you see, this part is, we already know, this part is given to be 0.3085. And so the total is 1. So what you do is 1 minus 0.3085, and that's going to give you 0. You already wrote there the answer, which is 6915, or you can say 69.15 percentage. Okay, part B is done. Now part C. Find the probability that a randomly selected person lives between 61 and 70 years. So basically we need to find probability of X between what? 61 and 70. 61 and 70. So we need to change this into Z score, okay? To change the Z score, what you need to do is Z value for, so Z value for X equals 61, you can calculate that easily, which is Z equals X minus mu over standard deviation. And then what is that? It should be, I believe, negative 0.88. And Z value for X equals 70 is Z equals X minus mu over standard deviation, which is 70 minus 75 over standard deviation 60. If you calculate, it's going to get negative 0.31. All we need to do is we need to find the value between this, right? So basically we're going to find, let's say this is our Z curve. And so for Z curve, mu is always 0. So we're looking for negative 0.3. Okay, negative, let's say this is negative 0.88. And let's say this point right here is negative 0.31. So basically we're looking for area between these two. And you know the value, right? So basically what we're looking for is probability of Z lies between negative 0.31, negative 0.88. So that gives me P Z negative 0.88 minus P Z negative 0.31. So if you calculate this two together, how much do you get? This guy is 0.3783. Okay, my table tells me this. So if I copy the wrong number, please let me know, okay? And when I look at the table with negative 0.31, this is what I got, 0.1894. Am I correct? And when I subtract them, I'm gonna get 0.1889, or about 19 percentile. Is that right? Okay, I believe you got the 19. You already put the answer in the chat box as 19. Okay, thank you. Okay, that's it. Now part D is, what is in part D? Part D tells us we want to be 90% confidence, right? So we want to be approximately 90% confident. Approximately 90% confident, meaning the probability. So what is given is, given probability is 0.90. Okay, 90%. If you change this into decimal, that's what you're gonna get, 0.90. Which one is the closest value? So for probability or area, because we define probability as area, right? For probability, which is equal to area of Z curve, area of Z curve equals 0.90. Z value is, let us calculate what is the Z value. So let's go all the way down to the table. We are looking for 0.90. Where is that? 0.90. Look at the table. Approximately 0.90. 0.90 is, this is 0.8962, 8988, 89797, 90. Okay, which one is closer to 0.90, 0.90? Is this closer or this one is closer to that? Which value is closer? We're looking for approximate. I believe this one is closer because there is a difference of just 0.0003. So this is the closest value in the table. So for this one, what is the Z value here is, Z value for that is, okay, Z value is 1.28. So this is 1.28. All right, so let's go all the way up. So we know the Z value, we are looking for X value. Okay, Z value is 1.28. Now what we want to do is we need to find the X value. Okay, so we find X value here. And we know the formula, right? So we know Z equals mu minus, X minus mu over standard deviation, which gives me Z value we already know. Z is 1.28. X we want to find minus mu is already given. What is mu again? Is that 75? And the standard deviation is also given. I think this is 16. So you solve this. So you're going to get X minus 75 equals 1.28 times 16. And so X equals, I don't know, 1.28. You use your calculator, plus 75, and I don't know how much that's going to be. Is that approximately 90? Okay, can you tell me how much is that? Okay, my calculator gives me 95.48, but I want to verify that answer with you guys, okay? So what it means is we can be 90% confident. So we can be 90% confident that a randomly chosen person is younger than 95.48 years old. Okay, that's it. So we are done with normal curve.